Well, welcome everybody to our August edition of the Engineering Academy webinar series. I got choked up there a little bit. I was so happy to be here with our guests. Uh, we have these seminars and webinars once each month on the third Tuesday of each month. So make sure that you keep those on your calendar, and we'll have various guests from time to time talking about things that they are expert in when it comes to broadcast engineering, both radio and television. Our program today, as usual, is actually sponsored or underwritten by Max Connect. Max Connect was actually with our engineering conference that we just had this past week up in Birmingham, and they set up all the Wi-Fi for all the booths that we had set up in the hall there. Max Connect is a nice little unit that actually uses a dedicated IP or Wi-Fi carriers. It's not actually tied into the ones that everybody else uses for their cell phones, and they're really nice to be that you can use with on remotes or even backup SDLs. So if you get a chance, we encourage you to check with them at www.maxconnect.com, and they have a host of other uh, uh, different types of equipment that they offer as well. But this is a really neat little device, and it worked very well up there at Birmingham at the convention. We wanted to follow up on an article, a couple of articles that we had in the our weekly newsletter concerning generators. And one of the most embarrassing things is when the commercial power fails, so does your generator. It doesn't crank, and you go out there and have to try to get it cranked, and it's maybe in the pouring down rain trying to get the generator cranked and everything. So when we uh, the first segment that we put in our newsletter, we talked about that, and my good friend Andy Butler, with who is senior systems engineer, I think is his title. He can correct me if that's not correct, but he wrote back with some really good comments, which we added in our next week. And I said, well, why don't we just have you on for one of our seminars? And so that's what we're going to do. So I want to introduce him now. And I've known Andy for a long time. He was president of the SBE, and we were just trying to remember when he was actually the president. And neither one of it. It's been so long we can't remember, can we?
No, it's
But he's been involved with SBE for a long time, and that's how I got to know Andy many years ago. So, Andy, you had some good thoughts that you sent to us on an email that we included in our newsletter, and wanted you to expand on it a little bit this morning.
well, thank you, Larry. I appreciate the invitation. And I, you, you said we had an expert. Well, I have a lot of experience. And the question is how much experience translates into expertise. So with that caution, I'm going to give you my opinions on quite a number of, or several things about emergency power. And one of the key questions is, let's see if I can get myself, yeah, there we go. Let's see if I can get the right clip there to share with you. And hopefully you're seeing my slides now.
Yeah, we got them.
Okay, good. And Larry asked the right question about emergency power. Will it be there when you need it? And that is absolutely the test of an emergency power system. It needs to be there every time you need it. And as Larry said, it's really embarrassing when it's not. So how can you make that happen? Or what are some things that you can do to make sure that happens? Well, I have some suggestions. I actually believe that there are 4 keys to having an emergency power system that will perform when you need it to. So what are those things? Well, the first is thoughtful design. This is something that, you know, you may not have had a part in, or you may have. Hopefully you did. And hopefully whoever put your system together put some careful thought into it. And unfortunately, sometimes they do and sometimes they don't. So if they don't, then you have to put there's some thought into how you're going to change that design to make it do what it's supposed to do. Another one is clear, accessible documentation. And there's a story I'll tell about this one in a few minutes. The third is pretty obvious. It's routine maintenance. And, we all know we need to do that. Emergency generators in particular require some special maintenance. And the last one is one that I was actually commenting on after the article was published, and that's realistic testing. And we'll take a look at what that means a little later on. Now, as I said, I will not pretend to be an expert in all things emergency power wise, but I've installed emergency power systems in stations from little teeny tiny stations out in rural Missouri to New York City. And while they're drastically different, also here at PBS, of course, while they can be drastically different, there are some things that are very common to all of them. So I'm going to talk about those, and I'm going to try to blow through this fairly quickly so that we can get to questions, because I think we probably have more people out here who know more about emergency generators than I do. And so we'll want to share your ideas. So we said thoughtful design. This is the 2 megawatt emergency generators here at PBS. Now, as I said, we're a national network, so we do things perhaps a little bit more than a local station would do, but there's nothing more essential in the distribution of emergency information than the local broadcast stations. That's where people turn when the skies turn black and things look pretty grim. Talking about thoughtful design, there are a couple of things that I wanted to call your attention to. And you'll notice that there are 2 identical emergency generators. We have 2 complete separate power systems, either one of which can carry our full load. As I said, these are megawatt generators. We have them tapped back to 750 kilowatts. Our normal load to carry our entire technical center is about 300 kilowatts max. That's with the tower lights on and everything, more than one uplink HPA powered up. So that's a pretty reliable number. What I wanted to talk about here is you'll notice that the 2 generators face different directions. Now, this isn't by accident, and it isn't because we like the way that looks architecturally. It's because here in the Washington area, we have some horrendous ice storms. Now, I'm pretty sure that you know what ice storms are in Alabama too. So it's something that you need to anticipate. One of the things that happens here is when we have an ice storm, the wind tends to blow the precipitation into the front of the generator, which is where the radiator is located, and the radiator freezes over. Then when the generator starts, you have kind of a race with no real winner. And the race is, will the generator be able to melt the ice off of its radiator before it overheats? And most of the time you lose. So in order to protect against that, we face the generators different directions. And like I said, that's one of those thoughtful design things. We could have faced them any direction, but we tried to make sure that at least one of them should be facing away from the prevailing wind. Also, you'll notice the concrete pilings underneath these generators. There's 6 of them under each generator. One characteristic of diesel powered generators is that they vibrate. And no matter how the designers try to get around it, diesels vibrate. And they do have cushion mounts, springs, various kinds of shock absorbers. They're sort of effective, but not completely. So to deal with the vibrations, we're sitting on marine clay, which is, I've likened it to silly putty. It never really compacts and forms a solid base. So each of these columns surrounds a piling which is driven down to bedrock, which where we're sitting is about 40 to 50 feet underground. So with those 6 pilings driven to bedrock, we're able to have the generator sit up here and vibrate all it wants because it's sitting on bedrock. It's not going to go slipping away. And if you look over to the right-hand side, you'll see this little Catalyte generator. This belongs to Verizon Communications. They're a tenant on our microwave tower. And one of the things that happened was when they first put this generator in, they set it on a slab up here. And the thing actually fell down the hill twice when it was running during bad weather. So we, of course, why does it matter to us? Well, first of all, we don't like fuel spills, but more importantly is Verizon is our wireless communications provider. So when their site, this particular site goes down, we lose cell service, which, when things are in an emergency situation, communication is pretty key. So we gave them an improved foundation for their emergency generator. This actually, you can kind of see the chunk of concrete here. That goes down about 20 feet into the ground, and that gives it enough mass that it won't float away. So, from PBS to Verizon, congratulations. There's the amount that will keep your generator where it belongs. Excuse me. Okay, so that's a little bit of thoughtful design. More thoughtful design, this looks like, this is our parking lot, but more importantly, this is the top end of our 5,000 gallon underground storage tank. Now, one thing that is characteristic of diesel is that when the fuel gets cold, it tends to gel. In fact, when it gets down to the average in the teen temperatures that we have here in this area during the wintertime, it turns to something very close to jello, which is really hard to pump and even harder to push through the diesel injector system. So one of the easiest ways to get around that is to keep the fuel underground. We have a double-walled underground tank, as I said, that holds 5,000 gallons. That will run this network operations center for about 9 days, which if we can't get a refueling truck here in 9 days, the world has come to an end and probably nobody's watching PBS. The reason for the double-walled tank is it provides a cavity around the contained fuel, and we can and do sample that cavity for both vapor and liquid leakage. The last thing we want to do is be spilling diesel fuel into the ground, particularly into marine clay. So that's one of those thoughtful design things. It keeps the fuel, never goes below roughly 50 degrees, no matter how cold it gets outside. And at 50 degrees, it's perfectly fluid. That's, once again, thinking about your conditions as part of your design. This is a shot of the oil lines running from our underground tank, the line on the bottom, and returning to that underground tank. Now, you may say, well, what in the world is that all about? We actually run the pumps that fill the day tanks on those generators continuously. And what that does is it pushes the fuel into the top of the tank. And if the diesel is consuming part of it, then only a portion of it is returned to the supply tank. If the diesels aren't running, then all of the fuel is returned to the supply tank. And that does two things. It helps make sure that the fuel doesn't turn to jello in the day tanks. And it also means that the fuel gets stirred, and that keeps it from separating and stratifying and becoming a problem for that reason. So for a little bit of electrical power and some maintenance, we continue to help maintain the integrity of our fuel supply. And that's, once again, thoughtful design. They don't, the manufacturers don't suggest that, but it's the kind of thing that can make a big difference in whether or not the generators are reliable. Another part of thoughtful design are the things that complement the base equipment. One of those things, as I mentioned earlier, is monitoring. This is the monitor box for our fuel tank system. And as I said, it monitors for both fluid leakage and fume leakage. It also keeps a pretty careful eye on the total amount of fuel in the system. And if it sees that total amount of fuel dropping by any significant amount and the generators haven't been running, then it alarms. It says, you're missing fuel. Do you know where it went? And that's a question we really want to be able to answer because of the environmental impacts, and also who wants to run out of fuel when you got a 5,000-gallon tank. Another part of the thoughtful design is how you support yourself, or how you support the people who have to support your equipment. And this is a 200 amp breaker panel. And there's one of these inside the housing for each of our generators. And what it does is it supplies the power for the lights, which are inside the enclosure, and they're also outside around the enclosure. So you can see what you're doing, no matter how foul the weather may have become. Of course, the other things that it powers are the control modules for the generator, the heaters for the generator coolant, and also the convenience outlets, as I call them. There's 5 or 6 of them spaced around the generator enclosure, both external and internal. So if you need to plug in a power tool or a piece of test gear or an emergency pump or something like that, the connection is right there. You don't have to birth babies to try to run an extension cord across the field and into the building, that kind of thing. It's right there for you as long as the power's up. And of course, these panels are on emergency power, and we'll talk about why they're always powered in a minute. Another piece of thoughtful design is something that we don't all have the ability to provide, and that's a UPS. Now, this is a 750 kilowatt UPS. There are two of them, one for each power chain in our installation. And this is what I like to refer to as a full facility UPS. In other words, this UPS carries all of the technical equipment. The only thing that we don't have on this UPS are the HVAC units, because mainly because they generate such horrendous spikes when they turn on and off. And that's something that UPSs don't tolerate very well. One of the reasons that I like total facilities UPS, if you can do it, is because they actually run the load all the time off of the batteries, so that the load power is isolated from the public power grid, which tends to ensure that you have less spikes, less nasty artifacts tearing up your equipment. And I first became a really great fan of this when I was taking care of facilities in Chicago and New York City. Surprisingly, as an example, the power in Manhattan is god awful. It just it'll, as they say, it'll tear up a light bulb, and what it does to electronic equipment is absolutely incredible. So that's where I got to be a fan of trying to do entire facility UPSs. I don't have a great deal of love for the little individual rack UPSs where you have to have one in every rack, because as soon as you get more than 2 racks or so, then you've got a maintenance monitoring challenge that can catch you by surprise. So, no, that's the reason I'm not a big fan of those. The other thing, people always ask, well, how long should I plan on the UPS lasting? Well, the primary job of the UPS is to maintain the load while the emergency generators are starting. So it's to bridge the transition from utility power to the generator power without interruption. And that is a pretty important thing to do, depending on your facility, but it's a pretty important thing to be able to do. So these UPSs running at our normal roughly 300 kilowatt load will last about 40 minutes. And that number is a good guesstimate within affordability of how long it will take us to get one of our diesel mechanics here from off-site. And that's kind of what you want to be able to protect. Is if one of the generators doesn't start, obviously the other one can carry all the load, but then you're single threaded, and that's not where you want to be. Another part of the thoughtful design is if you have a UPS, it's going to require maintenance and it can fail. So in either of those situations, you want to be able to bypass the UPS. Now, most UPSs, this one included, have an internal bypass, but most of the time, if a UPS has died, it's because it has some kind of problem with its brain with this controller right here, and then the internal bypass won't work. So having an external hard bypass is really good insurance, because then you can actually make sure that the unit is completely bypassed, and you can either run, if the generator's on, run on the direct generator, or if you're on utility power, run on the utility power while you deal with the UPS problem. Once again, that's thoughtful design. There's another really nice device to have, and that's this. It's an STS. It's a synchronous transfer switch. Now, we try to insist just as much as we can that every single device that we have in our facility is dual powered, has dual power supplies. That way we can put one power supply on power system A, the other power supply on power system B. So even if we lose one of our two power systems, that piece of equipment should continue running on the other power supply. The problem with that, of course, is that there are some devices that just don't offer the option of dual power supplies. And they're things that we can't live without. Picture monitors, test equipment pieces, even some broadcast gear. And to protect those, we use a single corded device power subsystem. And that is fed by this STS. What the STS does is it has both power buses available inside, and it monitors them both. It normally runs on power system 1, but if power system 1 is having trouble, the STS is pretty sensitive, and it will seamlessly switch over to power system 2. And that keeps our single cord devices running. And by the way, those support panels that are in the generator cases run off this power bus as well, so that they should always be powered up as long as there's some kind of power available at the facility. So that's the main parts of thoughtful design for power systems. One other thing is, if you have a UPS has batteries. If you have batteries, they require maintenance. And it's really tough sometimes to keep track of a couple of hundred batteries. That's what these devices are for. This is one of a number of different manufacturers. This is an Owlbear, but there are 5 or 6 others. What these do is, by using multiples of these, they actually monitor the health of every single battery individually. So you can see if you have 1 or 2 batteries in a string of, say, 20 that are starting to fail. That way you can maintain them or replace them before they become a problem or become a significant problem. And that, once again, is thoughtful design. You don't want to be caught with your batteries down, so to speak. One final thought is, this is kind of, people kind of say, well, what in the world does that have to do with thoughtful design? Well, one of the most common failures, or one of the most common causes of generator failures, are control problems. And that pretty much covers a very wide range of different things. But one thing that really gives externally mounted power generators fits is lightning. So once again, for thoughtful design, you should invest in power or in lightning protection for your emergency power system, so that you don't have to replace those $1,500 a piece controllers 3 or 4 times a year. Or, you know, the way lightning plays with you, have two controllers down and not have either emergency generator where it wants to start. So that kind of wraps up my thoughts on thoughtful design, and we can talk about your thoughts on thoughtful design when we get to the questions and answers. The next part is clear, accessible documentation. Now, one of my earliest mentors in this business used to say that a facility should be built and labeled so that any competent broadcast engineer can walk in and troubleshoot problems without having to juggle drawings or pour through manuals. And there's a good deal of truth in that for a number of reasons. First of all, there are a lot of circumstances where people don't pay attention to a particular system until it breaks. Emergency power is one of those. And the second one is you will inevitably have contractors working on systems, whether they're electricians or diesel mechanics or control people. If you can give them readily available rock solid information on what they're looking at, it can save you a lot of grief. And I'll show you some examples. This is the outside of generator number one. Well, gee, don't everybody know that generator number one's the one that faces east-west and generator number two faces north-south? Well, people forget, and also contractors may not know that. So this little piece of signage has saved us some pretty major problems because it tells the electricians and also the generator technicians that they are working on generator one, and that generator one, when it's healthy, will produce 277 and 480 volts. It's produces that in a three-phase arrangement with a 4-wire connection. So that tells the electricians almost immediately, without any doubt, what they need to look for to make sure that thing is actually performing correctly. Another example, this is one of our numerous, we have actually 7 automatic transfer switches that switch our load from commercial power to generator power. And with that number of them, it's pretty easy to lose track of what they do. So this is what that little green square is. This tells you absolutely that this switch is concerned with emergency power distribution panel 2. And what feeds emergency distribution panel 2? Generator number 2. That's what feeds it. Now, come here. That's what feeds it. It can also be fed by the generator roll-up box. What all this is a big honking power connector on the side of the building, so that if we should, for some reason, manage to lose 2 emergency generators, we can back a trailer or truck mounted generator up to the building, plug it in, fire it off, and this will allow us to route it to, well, where's it go? Automatic transfer switch number 3, automatic transfer switch SCP, single corded power, automatic transfer switch HVAC1, which is one of our 2 HVAC systems, and then the SOC 2 building, which is the building I'm sitting in right now. So just looking at the front of the transfer switch, you know exactly what it can do and what it can affect. You mess with this switch, you're going to mess with these things. The other reason for clear labeling is this is 2 of our 6 switch rooms. And once again, if you go walking into one of these, you will notice that everything is labeled. And the reason for that is with 6 power distribution panel rooms, each of them, these are 2 of the more simple ones, each of them, you can put yourself out of business or hurt yourself or somebody else very quickly if you don't know exactly what every single one of these breakers, by the way, that's a 1600 amp breaker. If that thing trips, or if you're trying to reset the thing and you haven't cleared the load, it will break your arm. So, you know, self-preservation does play into the equation quite a bit. So that's my thoughts on accessible, clear documentation. Okay. And what about routine maintenance? Well, this I'm going to blow through pretty quickly, but what are the things that I think should be part of your routine maintenance? One of them is doing an infrared scan of the power panels at least twice annually. And this used to be pretty expensive to do, but thank goodness now with all of these great little devices we all carry, they have clip-on fittings for them that turn them into infrared scanners, and they're pretty cheap. And knowing what's getting warm in your power panels or distribution system is invaluable. We have saved ourselves, I don't know how much trouble, by spotting breakers that were starting to deteriorate. And yes, circuit breakers wear out. They absolutely do. And one of the few ways you can tell that they're starting to wear out is they start to heat up. So that, once again, is really good routine maintenance. Now, the other one is kind of obvious, but do these manufacturers suggested monthly and annual service on your generators? And if you don't understand that, it's well worth hiring your diesel mechanic to come on site and take care of this for you. The third is log the hour meter reading for each generator each week. This is kind of like, yeah, but you know how much your generator ran. Well, do you know for sure? You know, it may have started and run for a while, particularly on a remote site, when you didn't get notified. Whether it should have notified you or not, you didn't know. So you need to kind of keep track of how much mileage you've put on each generator. And one of the first questions that the manufacturer will ask you if you call seeking advice is, well, how many hours is on that unit? It's nice to know. Another one is to clean or change your diesel fuel quarterly. Now, this is probably overkill, but it's what we have to do here because our environment is not particularly friendly, even though we use an underground tank. So there are services, and most of them can be provided by your fuel provider, where they come and pump out the fuel from your tank and replace it. And what do they do with the other fuel? Well, they take it back, filter it, and resell it. So once again, it's the way to keep from getting in a situation where you have a lot of sediment, water, other pollutants in your fuel. The other part of it is testing your lube oil on the generators at least annually. The fuel oil, when properly tested, is like a roadmap of what's going to go wrong with that diesel. And it's, once again, invaluable information. And once again, your diesel mechanic can usually recommend a testing company if you don't happen to know one. This change air filters at least twice annually. Now, I'm talking about the air filter for the combustion air of the emergency generators. Those things clog up very quickly, particularly when you're out in even an urban environment. We have a problem here with the sediment that's created by car tires running on the Beltway, which is about 1/8 of a mile from us, and it clogs up filters really quick. Obviously, if you don't have combustion air, they're not going to start. Speaking of starting, the generators have a battery, just like your car or any other internal combustion device. Do a specific gravity check on the battery on each of your generators every month. And by the way, avoid the temptation to use a car battery for your starter battery, because car batteries do not take the type of charge and discharge cycle that emergency generators put on a battery. This is something that should be obvious, but a lot of people just don't seem to think about it. Make sure, particularly on remote located units, that your generator control and remote statusing are telling you the truth. And this can take a little work, because how do you test it? Well, we'll talk about that in a few minutes. And by the way, this is another one of those you learn by experience. Be sure to check your spares for fuses and circuit breakers, because as I mentioned, circuit breakers wear out, and you're not going to find a 1600 amp circuit breaker at your local electrical supply house, unless they have an industrial client that keeps those kind of things. It's just like trying to find one of these. This is a 1000 amp fuse. Let me see if yep. And once again, you're not going to find that at Home Depot or your local supply house sometimes. So you better have spares when you need them. That's routine maintenance in a nutshell. Now let's talk about realistic testing. Now this is what got me into this pickle in the first place. Was I commented on the idea of running the diesel generator weekly, which a lot of them are sold and delivered with an internal timer that kicks it off once a week to run. That's not a real great idea, because one of my rules is never run a diesel generator without a load. Why? For two reasons. Well, for one, mainly, is it causes what's referred to in the industry as wet stacking, which is a polite word for carbon buildup. And the carbon builds up both in the generator, in the cylinders, and also in the exhaust system. And that can choke off an emergency generator fairly quickly. And the other thing that it can do is, if you're out in a remote area and the generator has wet stacked and it does start, it'll start blowing out chunks of carbon that are a fire. And that can cause a brush fire quicker than anything. And that's not going to do you any good. So try to avoid ever running a diesel generator without a load. Which kind of brings me to my second point. An emergency generator system is a system. There's a whole lot more to it than just that generator. You've got transfer switches, you've got other devices that have to act properly to make sure that that generator is doing what you want it to do. So when you test a system, test the whole thing. What do I mean? Pull the main breaker and let her fly. Make sure that the whole damn thing works. This is something that you may or may not be able to talk the boss into. I consider it pretty essential, particularly for larger generators. That's a yearly stepped load test. And this basically is done by usually the diesel mechanics. They bring in a dummy load, which basically can take the full output of your generator, and they isolate the generator from the load and direct it to the load bank. And they start at like 25% of rated power. And they run the generator for 12 to 24 hours and make sure it continues to work correctly. And then they step it up to 50% power. Then they step it up to 75% power. And they sometimes, depending on the generator, will take it to 100% rated load. It depends. What does that do? Well, it's like running your standby transmitter into an emergency load. It actually forces the whole system to perform under load. And it is one of the quickest ways to root out pending diesel engine problems. And that's, once again, if you go to the expense of having a full emergency power system, knowing that it's going to work is awfully important, or more importantly, knowing when it's headed for a failure. Once again, check the current and voltage. That seems obvious, but a lot of folks don't really do that when they bring their emergency power system online. And by the way, of course, the only way you can do that is to run under your normal load with your normal load in place. This is something that is kind of requires experience and intuition, but you should be on site every time that the transfer to emergency power takes place. And the reason for that is that's when things fall apart. So if you are observing the power transfer, you can tell just by your ears if the transfer switch is not switching as quickly or as readily as it should. It kind of goes rather than chunk, and that is going to burn up eventually. So also, if you have a problem with one of, say you have a 3-phase transfer switch, you have a problem with one of those contacts, it may connect that phase later than the other two, which is going to cause some really undesirable cross-phase power spiking while the transfer is taking place. And you certainly don't want your recovery device to cause a failure. This is something that I have to do a little politicking usually to make happen, but you really should run your monthly generator load test at the absolute maximum power that your facility can consume. And what do I mean by this? Well, I'll tell a story. I had an 8-tower directional AM array, and we were doing maintenance. We had the standby transmitter, 50 kilowatts, feeding the array. We had the main transmitter, which had been giving us trouble, feeding the dummy load. Of course, that meant that the air conditioning system was working full time. But something that I hadn't anticipated happened. The tower lights came on. Well, for 8 towers at 5/8 wavelength at a fairly low spot on the dial, that was a lot of light power. And the generator just went and shut down. So once again, when you're running your monthly test, do everything you can to make sure that there's not anything in the facility that's going to switch on and push the generator beyond its load capacity. And this is the last one. And this one is something that you'll learn the hard way sometimes. And that's to watch very carefully for current in the neutral and for jitter between the phases. And those are things that can really cause problems, and subtle problems, with circuit breakers and contacts and electronic equipment. And the only way you can catch them is to check the neutral currents and phase jitter each time you run your monthly test. So those are my suggestions for realistic testing. So now it's time, it's your turn. So if you have questions, please present them now. I'll also, that's my contact information. If you want to send me an email or call me, I answer my phone, and I'm more than glad to talk your ear off, as you probably realize, having listened to me now. So any questions?
If you have a question, you could either type it into the chat box or just open your mic and ask Andy a question. Andy, I'll ask you a couple I had here. When you were talking about you made mention of heaters on the fluid system in the generator. Is it also recommended to have heaters on the engine block on a diesel engine? I've heard people talk about that.
Yeah, it depends. It depends somewhat on climate. The block heater is a really good idea if the generator's in a cold climate. Now, one of the things that I've learned through experience is the effectiveness of a particular block heater, or the effectiveness of a block heater in a packaged generator varies tremendously. So if you are going to use and count on a block heater, one of the things you want to do is take the temperature of the block on the opposite side from where the block heater is and find out how effective that thing is. You can't really, it's, well, I always say until it's too late, you don't know your block heater's not big enough.
Okay. Another question I had was about checking phase jitter. What is the procedure to, I know we ran into this once over in the station over in Macon, Georgia, that they had all kind of harmonics and stuff going on in the building, and it was causing havoc with remote control system, with automation systems. And it turned out that it was phase jitter between the phases. So how do you actually check that?
Yeah, that's a very good question. And you can get a sense of what it is by grabbing your oscilloscope and the proper probes and watching phases. Okay, that's not really the best way to do it, but if you have nothing else, that's at least a way to get some indication of how bad it is. The real way is to use a power analyzer. Now, there are several different brands. The one that I like, and the one that power companies will back off from, is Adranit's. And what that does is it monitors each phase and the neutrals 24/7, and it'll store normally up to 2 to 3 weeks worth of logs, and it captures the phase jitter and neutral currents, as well as the current and voltage on each phase. And one of the things that I like about Adranit's monitor is more than once I've been meeting with the local power company, and they're saying, well, you know, our power's just fine. And it must be something in your switch equipment has got to be doing with the problem. Well, reach under the table, pull out the Janet's instrument and sit it on the table. And they're going to say, oh, but it's possible it could be our stuff. Let's take a look. And winning the art or getting their attention is worth the lease fee for that Janet's box, in my opinion.
That we actually did that. Well, we didn't, but we had the power company come into that station and make it. It was actually the studio, and it was an old bank building. It'd been there for years, and the wiring was just atrocious downstairs. And so they hooked up. I don't remember the brand name, but they hooked up something and let it run for several days. And one of the things I found was neutral current, which at that time I had never heard of neutral current, but theoretically you should have zero current on the neutral leg, because if you do, you got a problem somewhere.
Right. And it's really easy to neutral current is relatively easy to measure. And it's something that you absolutely, will absolutely indicate that there's something you should check or something that you should understand. Now, it can be caused sometimes simply because the load isn't evenly distributed between the phases. That is something that you can work with your electrician to shift things around to, as best you can, balance the load, which will minimize the neutral currents. But you're right, Larry. If you have neutral current, you have trouble somewhere.
Yeah, that's exactly right. Well, Andy, I appreciate your time today. That was most informative, and everybody that was on the call, we have. He actually sent me a PDF of the slides. If you would like a copy of them, just let me know. And this particular presentation today will actually be archived up on our YouTube channel. So if you want to watch it again, or if you have somebody that you think might that didn't make it, and you would like for them to watch this, just go over to the ABA Engineering Academy YouTube site, and you will actually you can watch it. I'll have that up later this afternoon when I have time to get it edited and put up and everything. So with that, Andy, I thank you and appreciate all your hard work in putting that together. And I'm sure these types of things will be very useful to anybody that is running generators and all.
Well, you're welcome, Larry. And I'm more than happy to share what I have. I tell people I earned this gray hair the hard way. So, I'm more than happy to talk anytime. So,
well, we all have been that way. And so we'll take all that to heart, and then we'll figure out what we need to do it. The testing of the generator, people say, how you actually do that under load. You just go out and you pull the breaker.
exactly.
And obviously you'd want to do that after midnight. I'm not sure why Jeff Weldon's picture popped up on the screen.
Well, I like Jeff, so he's welcome here.
That's right. Well, he's very good when it comes to grounding and doing proper grounding, and so that was really good. These slides, these are not the right slides. I was telling him we had problems, so just disregard that. So we want to thank you for watching today, and join us again back in September for our next engineering webinar. Thank everybody, and see you next month. Thank you, Andy.